So the first thing, let me go pull up the calendar page here. So first thing is Thursday, there's a test, and so I'll have like a sample it's to talk about here in a little bit. Before that, though, there's the first homework assignment, and as I mentioned, the class is a little weird. They don't have like specific due dates for these things, but I would recommend you finish the first homework, or at least work on it and know how to do it by around Thursday, because you should know how to do those things on the little test. So you should be working on that first homework assignment. Are there any questions about it so far? Okay, I did post up your second assignment, and then I did want you to turn them in on Blackboard. So one thing here, did I start my, oops, I did start it. So let me just show you on Blackboard what I'd like you to do. So if you go to the web page, here's the second assignment over here. And so kind of loosely, you should plan on finishing it around the next Thursday. So not this Thursday, but the Thursday after. So for the homeworks, what you should do is you get your programs working or whatever. If you're using like NetBeans for something, then go to your project folder. Let's see, NetBeans projects. So here I have a bunch of stuff here. But if you find the one that whatever is yours, so if it was trivia, how about pick this one? If it was, I'll just leave that one. If it was trivia refactoring was the one that had your project in it, then previously we said if you right click on it and do send to compressed zip folder, and that makes the zip file that has everything inside that folder. And so you could turn that in. Alternately, you could turn in just your .java files. Don't turn in your .class files. So for example, Dropbox. So here I have this Java program that I've been running. That's this one right here. That's the drew the rectangle. So whenever you compile your programs, it creates a file called where am I? Called whatever your program is .class right here, and that's the compiled version of your code. And so that one, that's the one you would give to people if you wanted to like distribute your code so people could run it, but it doesn't have all your source code in it, so it's unreadable. It's like in machine readable format. So for me, I need your .java files. So make sure you turn in only the .javas. You don't have to turn in all the .classes. So to go turn them in, I made a link over on the corner for assignments. So just go there and then click on like homework number 1, and then it's got the usual thing here where you can browse and find your zip files or your .java files. So you'd find those and attach them, and then just do submit, and then that's it. So don't do the save. You could save it, but if you save it, it's not submitted, and I can't read it. So if you could do those whenever you're ready, then I'll go check them out and let you know which ones are working or if they're all working. And usually you have a pretty good idea if they're working or not. Once in a while, there'll be a case where you think you have it working, but then you did it like a way I didn't ask you to do or something, in which case I might come back and say, here, you need to fix these parts. But for the most part, if you read the assignment and it's supposed to display a picture, if yours displays a picture, then it's probably working correctly. Okay, so that's the homework. So any questions there? So you should be working on that one, and then you could start working on the second one too. I just put that one up. Well, we haven't quite covered stuff to do it all yet, but you could start it if you wanted to read ahead. Okay, and then so the next part is we have these tests coming up on Thursday, and so what I'm planning to do is have it be like right at the beginning. So you come in here, and right at 11:30, we'll do the test, and they're very short. I have a sample one to show you. And then after it, we'll probably maybe give you 30 minutes, and then after that, then we'll have like a shortened class, and then a regular lab drill time. So the idea behind these exams is they're like basic, fundamental, in-your-face stuff. They're not like the usual exams where there'd be like a range of like subtle questions where if to get the A, you'd have to get all the subtle questions right in addition to the basics. These are all basic questions. They're kind of like the drills. And I'm doing this thing I haven't tried before where if you don't get them right, then I'm going to ask you to redo them until you get them. I guess I have to rethink that because you could just not take it at all, or you could just intentionally miss them all and then just redo it, I guess, which anyway, I'll think about that. So I guess your incentive for doing it, studying and getting it the first time is then you just get it out of the way and you're done, as opposed to having to redo them over again. So here I'll show you a sample one from a previous year. Where is it here? Sample. So here's like some example. So they're pretty fundamental. If you've been working and doing the programs, they should be pretty easy for you. If you haven't been doing the programs or the drills, and you might have a harder time. So example, which of these following identifiers are invalid and why? And so if you remember the thing about identifiers, then you should say, oh, this one's okay, it's all letters. Letters and underscores are okay, so that one's fine. This one, you're not allowed to make non-alphanumeric characters except for the underscore, so the sharp makes it invalid. This one, you're not allowed to have spaces, so it's not invalid. So you just say that about these bottom two. So shouldn't be anything super tricky there. Which values are stored after this code? So here's where you'd have to say, oh, x is an int, and here we're doing integer division. So 7 divided by 4 gives me 1 because I can't store 1 point something. So you just get 1 here. This one is like testing your knowledge of precedence. So you do division before addition. So 4 divided by 2 is 2. 2 plus 4 is 6. So you should get 6, as opposed to 8 divided by 2 giving you 4. So I know you do the division first. And this one is just modulus. Do you know what modulus is? So 9 goes into 22 times with a remainder of 2. So the answer would be 2. And then we haven't talked about, we're going to talk about this today. So maybe I'll skip this one, but basically it's an if-else statement. So that's today's stuff. I guess here's another one that's today's stuff. So maybe I can't say too much about that one yet. I guess I can post this online so you can take a look at it after we talk about if statements today. This one, I guess this one maybe doesn't work because we didn't talk about class variables in this point yet, so you could ignore this one. So, and then this one, let's see, write code that could go into the main method that asks the user to enter length in feet, inputs an integer in feet, calculates the corresponding length in meters. 1 foot is 0.3048 meters. So you should be able to write the code that would print out, enter a value in feet, read that in as an integer, compute the corresponding length in meters, and then output it. So it's like 4 lines of code, something like that, 4 or 5. You wouldn't have to write the whole main. So basically it'd just be the stuff inside main. You wouldn't have to write the whole import stuff, public class, whatever. So all that stuff, don't worry about, just the stuff that would go inside the main. And then that's it. So should be pretty short and sweet. and hopefully no problem for all of you. So any questions about what you're looking at on Thursday? Okay, so I'll put this online if you want to check it out, especially since we haven't talked about the if statements part yet. Okay, so we were talking about colors or how to draw stuff. So let me just briefly go over what we had done previously. So we said to make a program that can draw stuff on the screen. Here's kind of a template, and there's a fair bit of stuff here where it's kind of don't worry about what it is yet. Just do it for now, and then we'll talk about how that works later. So we were saying that here's your template. We have all these extra imports up at the top for JFrame, graphics, and color. And then we add this thing extends JFrame over here. We have the word public, and then this thing, whatever is the same name as your program. So if your program is called Java program, this would be also called Java program. But then you have left and right parentheses here. This thing's called a constructor. And then inside here we have these three things that would set the size of the window. I just made mine a little bigger. So it's 500 pixels across and 600 pixels down. This next line makes it so your program will close when you click on the X. This one makes it visible. And let me skip over the paint for a second. And then we said inside the main, you add this, whatever your name of your program is, and then you can pick a name here. I called it my window, equals new, and then name of your program. So basically this is creating an object that corresponds to your program. And when it creates the object, it calls this thing over here automatically. So then it's going to run these 3 lines of code that set the size and make the window visible. And then anytime the window needs to get redrawn, it's going to call this paint method. And this thing G is called a parameter, and it's basically like the canvas for painting stuff on. And you have to add this first line just so we can handle it correctly. And then we have, these are the 3 lines, basically where we started doing stuff ourselves. So here is where we set the color. And in this case, we made the current color red. And so you can think of this as like you have a pen in your hand, and you just grab like a different color, and you can only have one active color at a time. And so right now the active color is red, and then it draws a rectangle. And the rectangle is drawn where 50, 50 is the coordinates of the upper left-hand corner, and we have this coordinate system where 0, 0 is the upper left corner, and in this case we went 50 over and then 50 down. And then that's the upper left-hand corner of our rectangle. And then we specify how far over we go and how far down we go. And then it would fill in the rest. So this one said to go over 100 pixels and then down 100. Let's change it to 50. So we go over 100 pixels and then down 50 pixels. And then draw a rectangle like that. And it should be red. And then this one draws the string that says moof. And it's at upper left corner 200, 200. So if we compile this and run it, then here's my rectangle. It was the 50 starts really in the upper left corner of the whole thing. So it went 50 over here and then 50 down. And then we drew it 100 pixels over and then 50 pixels down. So that's a width of 100 and height of 50. And it fills in that rectangle, or outlines the rectangle. And then this moof is set up so I had it at 200, 200, and so it went 200 pixels over, 200 pixels down, and so this upper left corner of the M should be at coordinate 200, 200. Okay, so any questions so far? So once again, don't worry about all this template stuff. The part you need to know is basically that if you're going to do a graphics program, then you just have to recreate this whole template here. And then the part where you really need to think about would be like colors and rectangles and the coordinates. So these 3 lines. Now if I pick a different color that's not red, like I pick green, then we should see this thing show up in green. So there's our green over here. It's a little hard to see. So we have like basic colors here: green, red, blue, black, white, magenta, red, orange, gray, yellow, pink, cyan. So we have our basic colors you can just call by name. We also have a way you can construct the color yourself. And if you're going to construct the color yourself, then it uses the red, green, blue color model. And so the idea is red, green, and blue are like the component colors. And then you combine them, kind of like you combine paint or light. And then when you mix red, green, and blues together, you get other colors. So the idea, if you mix red, and blue, you get whatever that is, magenta. If you mix all three, red, green, and blue, then you get white. And that's if you have like the brightest red, green, and blue, you get white. If you have like a not as bright red and not so bright green and blue, then you get like more of a gray in between. And then if you have 0 red, 0 green, and 0 blue, then you get black. If you mix red and green, you get yellow. And then, so this is if you mix like the pure red and pure green and pure blue. If you mix like shades of them, and so it turns out instead of values that are just pure, you can specify the amount of red from 0 to 255, and the same thing for green and blue. So if I had 0 red, 0 green, and 0 blue, then that's black. If I have 255 red, 255 blue, and 255 green, then that's white. And if I have like 0 green, 255 red, and 255 blue, then that's the magenta that you see right there. So right here in this one over here, it's showing the mixtures if you had 255 for the red, green, and blue. If you have smaller values for the red, green, and blue, like 0 or 70 or whatever, then you get the different colors shown on this color wheel. And this doesn't show all the colors, but it shows some of them. Like it doesn't show black, for example. But you can get like different shades of magenta over here, whatever, like raspberry. If that's 255 red, 0 green, 125 blue. And then spring green over here is 125 red, 255 green, and 0 blue, and so forth. So the idea is by combining the red, green, and blue, which are between 0 and 255 each, you can get all the different colors on the color spectrum, at least that are visible to most people. And you could have finer grain colors in some cases that you just can't represent, but it's usually good enough to look decent. So if you want to make your own color, you can do that as well. And so let me go down here. Instead of color.green here, I could write new, and then capital C for color, and then in parentheses, give it the red, green, and blue values for the color I want. So if I want to see what 120 red, 55 green, and 208 blue is, then this would be some color, red, that's kind of bluish red, since blue and red are the biggest values. So I compile and run it. And there's my purplish light color, which I guess is whatever those correspond to. And so if you're really interested, you can look online and you can find a bunch of color charts and stuff that show all the different colors you get from different combinations of red, green, and blue. If you ever go and do like web stuff, like web design for web pages and things, it uses the same color model for specifying colors of stuff on a website. So it's not just used here. Okay, so any questions about that color model? So all right, so for our point purposes, it's not super important to get exact colors, but just to show you how you make colors, and as long as you get the idea that you can mix these different colors together, then that should be all you really need to know. A little later on, we'll do some stuff where we manipulate colors, like if you have something that's really red and you want to make it not so red, then if you decompose the color into the R, G, and B, then to make it not so red, you just decrease whatever the red value is, and then maybe you'd increase something else, like the blue and the green or something. All right, so right here we just showed how to draw a rectangle and to draw some text, and there's a whole bunch of other drawing functions. So let me just go over a couple of them here. Where are they? Here they are. Okay, so we've already seen set color is used to set your current color to something. Draw a line draws a line from this XY coordinate to some other XY coordinate. So pretty simple. If you want to draw a line from, like, if this is our screen and you want to draw a line that's like this horizontal, then maybe you might give it 10, 50 as the first coordinate, and then whatever 800, 50 as the second, and then that would draw a horizontal line from 1050 right here to 850 right there. If for some reason you want to draw a single pixel, like just one dot, then you can use x1, y1, x1, y1. So if this is like 50, 50, or how about 50, 100, 50, 100, and that's like saying draw a line from here to the same place, and you end up drawing one dot. So once in a while you want to draw a dot, and so here's a way you can do it. The way draw oval works is you have the same thing in here as like a rectangle. You give it the upper left corner and then the width and the height. So if you give it the upper left corner, the width and the height, so whatever this is, it's going to draw an oval that fits inside that box, but then doesn't show the box, so you just see the oval. So essentially, if you made a square, then it would draw a circle. If you made a tall, skinny rectangle like this, then you get like a skinny oval like that. So whatever your bounding rectangle looks like, the oval is going to be drawn inside of it. We already talked about draw a rectangle. Draw arc is how does draw arc work? Draw arc takes an XY width and height, so you have a bounding rectangle like with the normal rectangle, and then you give it a start and a start angle and an arc angle. And I forget which direction these go, but I think it goes. You can try. I think it goes like this. If this is the rectangle, imagine there's a crosshairs right in the middle, and I think 0 degrees is like here, and I think it goes out this way, but I could be wrong. We'll test it and see. So if you gave it like whatever coordinates here, and then start is 0, and then the arc is 45, then I think it would draw like this chunk of a pie inside the bounding rectangle. But let's try it and see. Let's get rid of that. We'll just do this one. Oops. Draw arc. Let's give it a square, and then 0, 45. So there we go. So there's a little bit of an arc right here. So imagine I had a box right here, and right in the middle here was 0, and then it went 45 out. So if I give it 90 as the arc, then it should make it go all the way up to the top here. So instead of just 45 degrees, we want 90. Now we can see instead of just going out 45 degrees, it's drawing the arc to 90 degrees. And if you wanted the arc to start at the top and go over, then instead of starting at 0 degrees, you could start it at 90 degrees, for example. So here it started right here at 90 degrees and then went out another 90 degrees. So that's the way the arc works. And if you wanted to, I think you can even give it negative. So I could start at 0 and go to, let's try it, negative 180. So here I start at 0 and I have an arc at negative 180 to go make a half a circle. Let's see, so that's draw arc. And then we have the same thing for fill. So instead of draw, you could substitute fill in its place. And instead of just drawing the outline on the edge, it'll fill it in instead. So here if I fill this in, and do fill arc instead, then it fills it in instead of just drawing the edge. So here I have a little sample program, and then that's pretty much all we'll say about this part for now. So here I set the color to yellow, I fill in oval, 50-50, 200-200. So here if I do this, so there's my yellow oval. So in this case the circle, since I made it 200 across and 200 down. And then to add to this a little bit, I'll do it this way. So can anyone tell me what color I just set the pen to when I use 00255? It's blue, yeah. So if you remember, so the first number is red, the second's green, the third's blue. So this is 0 red, 0 green, as blue as we can get. So this is bright blue. And I'll make a new color. So here it's 0 red, 255 green, 255 blue. So it's green blue. It's whatever that is, cyan or something. And we'll draw another oval in this color. And we'll do one more color. And this one makes it red. I could have just said color.red, but all right, so here I drew a couple ovals and a rectangle. So here is our, whoops, I messed up on this one. It's supposed to be an eye here, another eye over there. And then the mouth. So I put the eye in the wrong place. So what did I mess up there? That's this one right here. Oh no, this one right here. Should be 100. All right, so there we got our two colored-eyed smiley, not smiley, I guess ambivalent face. And if you're a little more adventurous, you could make a smile or something. If we use that draw arc, for example, we could make a nicer mouth. Okay, so that's it for now for drawing stuff. Any questions about that? So you should be able to do the homework question about drawing stuff. So what I want to move on to is making if statements. So far when we've written our programs, it's just gone straight down, done the first line, the second line, the third line, just cruises through until it reaches the end. And sometimes you want your program to make decisions to say, well, if this condition occurs, don't run this chunk of code, but do run this other chunk of code. And that makes your program start to do more interesting things when it can make these kinds of decisions. So like when we were doing the Twix bar calculator, there are a few people that are saying, oh, should we do it for both male and female? And well, we hadn't covered how to do that yet, but it would be nice if in your program you could ask, are you male? And if you say yes, then it'd do the male formula. And if you said no, then it'd run the female formula. So it'd be good if we could ask the user questions and then make decisions based on the input. Before we introduce how to do that, let's talk about a new data type. Well, we've mentioned it already. It's the Boolean data type. And it's used to store true or false. So this is how we'll make our decisions. If something's true, then do whatever. If it's not true, then do something else. And for the Boolean data type, you use the keyword Boolean, and then you pick a variable name, like whatever b. And you can write things like b equals true, or b equals false. And you can only set true or false to b. You can't set anything else to it. So that's all you can set it to is true or false. But more interestingly than these is you can use the common relational operators like less than or greater than or equal to. We'll say about that in a second. So we can do things like b equals 10 less than 12. So that's true. 10 is less than 12, and so b would be set to true. Or if we wrote b equals 10 less than 3, then that's false. So false would be stored into b. So this starts to get more interesting when you can use these relational operators. And so what are they? So here's our list of common relational operators. So if you want to check for equality, in Java you use two equal signs. So very important, you have two of them. If you have one equal sign, we've already seen we use that for assignment. Like when we said x equals 3 or something, we use one equal sign to copy 3 into x. So one equal signs for assignment, you have to use two equal signs for equality. So if you want to check to see if two things are the same, got to use two equal signs. What about for not equal to? So in math, you would have the symbol like that, but we don't have a key like that on the keyboard. So what do? Well, the inventors of C decided to use exclamation mark equals for not equal, and then that notation is carried over in most programming languages. So if you want to do not equal to, then it's exclamation mark equals. Some people call the exclamation mark the bang, so sometimes you'll see people say bang equals. So this is not equal to. What about for greater than? Well, fortunately we have a greater than sign, and so that's the same thing. Same for less than. Less than is just the less than sign. If you want to do greater than or equal to, there's the greater than sign and then an equal symbol. So that's just like you would expect. And then a less than sign and an equal symbol. So that's for less than or equal to. So there's all of our common relational operators that we can use. So a few other short examples. If I had this Boolean b, then I could write b equals 10 equals 12. And since 10 is not equal to 12, false gets stored into b. Or I could write 5 not equal to 2. So since 5 is not equal to 2, that's true. So then true would be stored in that variable b. Okay, so there's a few caveats though on using these operators. Basically, equals, less than, greater than, not equal to. They work fine on integer types. Let me back up here. So they work fine on integer types, but equals equals and not equals probably won't work correctly. On floating point types. So I say probably because you might get lucky and it might work. But if you try to use equals equals on floating point types, then you've probably seen when we were doing that stuff with like the Twix bars and you had the multiplication with the double, and when you print the number out, it was like whatever, 2.783476, whatever. You had this really long number. And so if you use equals equals on a double, it's going to check to see that those digits are exactly the same all the way out to the end. And because there's little bits of round off error, there's a good chance that they're not going to exactly match. So you might luck out, but there's a good chance it won't work. So here's just a little example. If I go here to this main, and how about I'll just do it right here in the bottom. If I say double D equals 0.05 times 3, so here in this little example, I have a double D that's set to 0.05 times 3, so that should be 0.15. And then if I check to see if it equals 0.15, then mathematically it's true. So I should have B is true. But then if I run this and look at the output, and the output's down here. So here you'll see the value of D is 0.15, and then a whole bunch of zeros with a little bit of round off error with that 2 at the end there. And so because of that, when I try to compare that to the 0.15, I get false. And so even though, so they're false from like the machine's point of view because they're really not the same. There's a little bit of differences way down here, but mathematically they should be the same. So you have to be careful. Basically, you shouldn't use equals equals on floating point types because it might not work. So we'll see there's a way around it. And basically the way around it is check to see if the number is greater than 0.149 and less than 0.151 or something like that. And if it's between that range, then you can assume that it's what you're looking for. The other thing you can't do, and we'll say more about it later, is also these don't work on strings. So we'll see we have a different way to work on strings. So if I had like some string variable s that we had read from the keyboard, for example, you might want to check if s is equal to hello, but you can't do it this way. So don't try it. We'll have a different way we'll use here in a few minutes or several minutes. Okay, so we've got relational operators like less than and greater than and equals equals and exclamation mark equals for not equal to. The other thing we can do is we can combine together trues and falses in logical ways. These are called the Boolean operators. And I think they mostly correspond to what you would think of would happen. And so the first one we have is the AND operator. And you might have seen these in like a logic class. Like if you take a philosophy of logic class, you would have seen this in excruciating detail. In Java, the symbol for AND are two of the AND symbols. And so the way AND works is you have like A ANDed with B, where A and B are true or false. So they're Booleans. And then we can make a little table about what we get as a result. So if A is over here and B is up here. So if both A and B are true, then the result of ANDing them is true. Otherwise, you get false. So basically, if A and B are both true, then the result of ANDing them together is true. And if either one of them is false, then the result of ANDing it's false. So it's kind of like multiplying ones and zeros. Or if you think of it logically, well, hopefully it'll make sense when we do this. We'll do some examples where we'll fill in numbers here. So essentially, if both of these are true, you get true. Otherwise, it's false. And then we have kind of the flip side of that. We have OR. In Java, the OR symbol is the two vertical bars, which is it's like shift backslash. So it's that key that's on the backslash key. And it's two of them. And it's the same thing. If you have an A and a B that are true or false, then the table that describes it is this. If any one of these is true, the result is true. And the result is false only if both A and B are both false. So it's one or the other. As long as one or the other is true, the whole thing is true. And we have one more, and that's the not. And the not just flips the logical value that we have. In Java, the not symbol is the exclamation mark. And you only have one value. So if you have like not true, then that becomes false. And not false becomes true. And then the way you use not is you stick it in front of the value you want to not. So not's like the inverse of whatever comes after it. So let's do a few little examples. So if I have a Boolean B, and I say B equals x less than or equal to 10, or x greater than 20, and normally I would put parentheses around the whole thing. Then, if x is some value that is 10 or less, you would get true. If it was 20 or more, you get true. Otherwise, you get false. So if x equals 15, then 15 less than or equal to 10, false. 15 greater than 20, false. False ordered with false is false. The whole thing is false. But if x is 1, then 1 less than 10 is true. 1 greater than 20 is false. But when you have the OR, if any one of the two sides is true, the whole thing is true. So then B becomes true. Here's another example. What if I did AND instead? Anyone see a problem if I did this? So the problem here is no matter what value I pick for x, it's always going to be false. There's no value that's going to be less than or equal to 10 and bigger than 20 at the same time. So, if I pick 1, for example, then 1 less than 10, that's true. This one's false. When you have the and, both sides have to be true for the whole thing to be true, so this will be false. And if I pick another like 15, then I get false here and false there. It's all false. I pick 30, and this one's false, this one's true, but one side has a false on it, so the whole thing is false. So this will always be false no matter what, which makes it not a very interesting statement to write if it's just false all the time. But if we do something else like this, like, I don't know, x equals 30, then here we have the options where if x is 10 or less, then you get, oops, I didn't mean x less than, how about I do this? X equals, I still wrote something that's impossible to get true. How about x greater than 5? So here be a case if I have a 6, 7, 8, 9, or 10, then I could make this thing true. Any other values, you would get false. And so it would have to be 6 because I have x greater than 5. If x is equal to 5, then this becomes false because 5 is not greater than 5. And then when you have a false and with anything else, you get a false. Let's see. So the case that we were looking at where I had that weird thing, I could say D is greater than 0.1499 and D is less than 0.1501. So if I wrote something like this, then this would be checking for the case where D is about 0.15 within whatever bounds I'm comfortable with, and then then that would make B be true. Let's see. So any questions so far? I can also write things like this: B equals X not equal to 0 and Y divided by X greater than 2. So here we have a potential problem. If X happens to be 0, then when you try to do Y divided by 0, you would get a problem. You get a division by 0, undefined number kind of problem. And then Java has a couple of ways we can get around it. One is it does this thing called a short circuit. And what will happen is, as long as the order is, we'll talk about it in a second, and there's an order in terms of how we evaluate these, but as long as we evaluate this one first, X not equal to 0, if it turns out that X is 0, then X not equal to 0 is false. And then since you have an and over here, false and with anything else becomes false. And so Java knows that it doesn't even need to bother to figure out what this is. If this side is false, then it just skips this whole calculation because it's going to be false anyway. And so that thing is called a short circuit. And in this case, that's helpful because if we continued on to evaluate this thing when X was 0, then you get that divide by 0 problem. But here we avoid it because Java skips this entirely since it knows it can't possibly, the whole expression can't possibly be true. But then if X is something else, like it's 1, then 1 is not equal to 0, that's true. So then Java will go on and evaluate what's on this side, and it'll do Y divided by 1 is Y greater than 2. If it is, then the whole thing is true. If it's not, then you get false. Okay, so the order that Java uses when you have these ands and ors is Java does not actually have a chart on it over here. And so Java does parentheses first. That's like the highest precedence. That's the order of evaluation. We talked about plus, plus, and minus, minus. So that's done next. Multiplication, addition is done before plus and minus. And then the relational operators would be done next. And then equals, equals, and not equals. And then and is done before or. And then we didn't really talk about these down here. There's assignment, but so the key part is and is done before ors. And so if we go back here, if we do something like this, count less than or equal to 10 and sum greater than or equal to limit or this. So if you wrote some code like this without any parentheses, which I would say is a bad idea, so normally you would use parentheses, but if you wrote it just like this, then according to our precedence rules, if I go to the next chart here, oh, I didn't put it on here. That's not good. So exclamation mark is done first. It's like up here with the high precedence. So we would do exclamation mark stop first. So it would be done after parentheses. So parentheses always go first. So we calculate exclamation mark stop first. So I'll put parentheses around it to show that this would be like the first thing we would try to evaluate. The next thing is the relational operators, the greater thans and less thans, and so those would be done next, and so I'll put parentheses around those. And then finally, we would do ands before ors, and so then this thing would be done next, and then the or next. So finally, if I want to put parentheses around the whole thing, this would be the order that we would evaluate this, as we calculate, count less than or equal to 10, sum greater than or equal to limit. Are they both true? If they are, then we could stop. Otherwise, we'd also look at not stop over here. So if stop, the opposite of stop is true, then that makes the whole thing true. So then we finally would OR together this side with that side. So normally when you write this, you would use these parentheses. So I'd say just get in the habit of using your parentheses, but if you ever see some code that doesn't have them, then those are the rules that we'd use to figure out what gets done in what order. Okay. So let me cruise on. So finally I can get to the if statement. And so it's pretty simple in its basic form. You have if followed by some Boolean expression. And then normally you'd use curly braces and then statements. You could leave these off. If you leave them off, then it's only going to do the next statement. So what's going to happen if I wrote this is you have to put the parentheses here. Java would come in here, see the if, whatever this thing is, if it evaluates to true, then it's going to run everything inside here. And if this evaluates to false, then it's going to skip it and go to whatever comes after the curly brace. So that's the basic idea. There's a modification to this called the else statement. And so if I move this up a little bit, I can use the word else. And if there's an else here, followed by its own pair of curly braces, then if this expression is false, it's going to skip to the else and then run whatever's in here. And if this is true, then it's going to go run what's in this first block. After the first block is done, then it's going to skip over the else and then continue with whatever comes after it. So basically, here's a way where you can control if you want to run this chunk of code or that chunk of code using the if statement. And we can expand on this. We can add multiple else's with an if after it. So let's do that one. So here's the most general form we've got. I can say, let's call this Boolean expression 1. And then I could write else if Boolean expression 2. And some code here. And then I could do another else if Boolean expression 3. And finally, I could do an else, whoops. So if I do this, and I can do as many of these else ifs as I want, if we start at the top, if this expression 1 is true, then we run whatever code's right here, and then after it we would go jump all the way down to whatever comes after this final else. On the other hand, if this expression is false, then we'll drop down to the next else and then test this one to see if it's true. So then if this one's true, then we would run code 2 over here, and then it would drop down to the end. And then if this one was false and this one was false, then we'd come down here and then check expression 3. And if this one's true, we'd run one over here, and then we'd skip over the end. So we can do as many of these as we want. And finally, if we have an else at the very end with no if, then if all of the above Boolean expressions are all false, then we would just run whatever comes after here. And these are optional. So once again, I could take all of these and I could leave them off if I wanted to just have the if by itself. But this is like the most general format that we could use. Okay, so let me do a couple examples here, and then I'll let you work on the drill. So let's do this. Let's comment this out. So this first example is, let's have a variable temperature, and somehow it gets set to a value. I'm just going to set it here directly, but maybe it'd be read from a sensor or something. So I'll say temperature equals whatever it is today, 60 degrees or something. And here's an if statement. If temperature is less than or equal to 32, we might decide 32 is our cutoff to be a comfortable temperature. Let's do a print line up here. So up at the top we print today is A, and if it's less than or equal to 32, we decide that makes it a cold day. And you should stay warm. Else it's a nice day, go outside. So in this case, when temperature is set to 60, it'll come in here and say today is a 60 is not less than or equal to 32, so we'll skip to the else and then just print nice day, go outside. So we compile it, try to fix my problems. And then there's our output, today is a nice day, go outside. And if we had it colder, like it's 30 degrees, then we get today is a cold day, stay warm. Let's see here. So that's one little example of using if else. Let's do one more. I'm just going to delete this. So a typical thing you might want to do is check to see if a number is even or odd. And so you could divide by 2 and check the remainder. If the remainder is 0, it's even. If it's 1, it's odd. So then you do something like this. If num %2 equals 0, then it means that num is an even number. So we can output oops, weird. Keep sticking there. So we come in here, 53% mod 2 would be 1, so that's false. So it should come out and just say odd. And I messed up somewhere. System.out.print. So here we get 53 is an odd number. If I leave the else off, then we'll come in here. 53 mod 2 is not 0, so it's just going to skip over the if part and then go straight to what comes after. So it should just print here. And so there I get the here. Let me do one more that has a couple of different ifs. So let's say we like to calculate taxes for different incomes. So maybe this is our amount. Let's just say it's an int. So maybe these are the tax rules. If the income is less than or equal to 15,000, then tax is set to 0. Otherwise, if income is less than or equal to 25,000, tax equals 0.05 times. So this is the idea that you get taxed on 5% of your income over 15,000. So you see language like that when you do your income taxes without these exact numbers. And then here's our catch-all. If you make more than 25,000, your tax is 5% of the amount minus amount over 15,000. Anyway, it's not too important here. I had this kind of weird formula. So here's this little strange formula. You get 5% on the amount between 15 and 25,000, but then 10% on anything above 25,000. So whatever your rules might be, you'd stick them in here. So here's the logic, that's the important part, and I won't run it really. So you would come in here, whatever income is, if it was less than or equal to 15,000, then we have no tax, and we would just skip down to whatever comes after here. If our tax was more than 15,000, let's say it's 17,000, then this part's false. But this one's true, 17,000 is less than or equal to 25,000. So then tax would become 5% times this amount, and then it would skip to the end. And then if our amount was anything else, which would mean that our income would have to be greater than 25,000, then this would be false, this one would be false. We'd come down to the else, and we would always run the else, and so then this would be the tax computation. Okay, so any questions on this part so far? So let me do one more thing. We can also put if statements inside if statements. They're called nested if statements. Let me just do a quick example back here first. So maybe we decide, well, if you made more than 25,000, maybe there's a special case if you made exactly $35,000. Then you could do something like this. If income equals 35,000, special case here, else. And we could just something like this. So this is called a nested if statement because I have another if statement inside this other if statement. So here's the else block for this outer if statement. So let's say I made $35,000. The logic is we'd start here. 35,000 is not less than 15,000. It's not less than or equal to 25,000. So we drop into the else part. And it is exactly 35,000, so this is true. So then it would run whatever special stuff I put here, which I didn't type anything in. And then it would skip this else and then skip to the end. On the other hand, if you made $35,001, then we would come in here and this part's false. So we do the else. And so then it would run this code right here. So you can put an if statement inside another if statement, and then sometimes that's helpful. I could also have taken this and flattened it at the top level. I could have like an else if income equals 35,000 up here instead. So you can kind of change your logic around if you like, whatever makes more sense to you. So we can put if statements inside other if statements. If you use those curly braces, then there's no troubles in terms of what matches where. But if you don't use curly braces, then you can run into problems. If you did this, so the problem here is there could be confusion where this else matches up with. If the else matches up with this, then you would get one thing, but you could also imagine the else could match up with the first if, which would give you different results. And so which one does it go with? Well, Java has a rule that if you don't have curly braces that force the else's to go with certain ifs, then the else is going to match the closest if statement. So in this case, this else is always going to go with this if statement right above it. The better way would have been to have curly braces. So if I was using curly braces, and there'd be like one right there and say one right here. Let's rewrite that. So the better way would be to put those curly braces like this, and then it's pretty obvious that this else goes with this if and not with the one above it. Okay, so there's that. So maybe I'll stop here. Yeah, so okay, so I'll maybe stop here and let you work on the drill. So with the drill, it's basically doing a couple of if-else statements, but then you have some more complicated ands and ors to stick in there than the examples we've just given. Okay, so any questions? All right.